substitution, elimination, all that sort of stuff. But the fact of the matter is, I didn't want to start off by giving you a 3 by 3, which is what you're going to need it for, or a 4 by 4. We're going to start small. So you're going to see how using matrices will help you solve these kind of equations, even though you can solve it in different ways. But then you're able to apply it to higher, to larger matrices. Yes. When you create a matrix, you create the coefficient of the answer. So it would be AX equals B. So it would be, my coefficient is 2, -3, -3 times 5 times X and Y equals -1, 3. With me? So your A matrix is this, right? Your coefficients. Your X matrix is this. Sometimes it's XY, sometimes it's X1, X2, X3, so on and so forth. And so this is your variable matrix, and this is B is the answers for each of your solutions, right? So just like with an equation that we did a little bit over when we did in previous lectures, if I have, how would I solve that?
Divide by 2.
Yeah.
Why would your instinct say to divide by 2?
To isolate X.
To isolate X, we do the
Opposite.
opposite, and if it's multiplied by 2, then we have to divide by 2. And what I do to one side, I have to
Do the
do
other.
to the other, giving me X by itself equals 3. You with me?
Yep.
Yeah.
Okay? So this is the same thing. And last section, you learned what the opposite of a matrix is. What would the opposite be?
Inverse.
The inverse. So it would be A -1 would cancel that out, leaving me with just what?
X.
X. Right? Now, what I do
If
to
you do
one
it to the
side,
other
I have
side.
to.
Do the
So I
other.
also have to multiply this by A -1. Yes?
Yeah.
But here's the thing. When I find the inverse of this and I multiply it, right? My inverse is going to be a 2 by 2, the same as this, right?
Mhm.
This inverse is going to be 2 by 1. If I multiply this, B times A -1, this is going to be a 2 by 1 and a 2 by 2. The middles are not going to match up. So I can't multiply those. But I can do what? A -1 times B. Because then this is a 2 by 2 and this is a 2 by 1. Now the middles match up. So I can't just do A -1 to right here. I have to do A -1 times B will give me the solution for X.
But that gives you a different answer. So
No,
how?
this is the only answer that you can get. The other way you cannot multiply.
What if you can do it either way?
You can't do it either way
Okay.
because of how it's set up. The inverse matrix always goes first. Questions on that?
Wait, what? The inverse matrix always goes first or else it doesn't work, is that what you said?
Right, because of what I just said over there. The middles have to be the same in order for it to multiply. So if the inverse matrix, you put it after, then you have a 1 and a 2. So the inverse matrix first goes first in the multiplication order, and then since the middles match up, and then your new inverse will be a 2 by 1.
In the last section, we had to find AB and then BA. We're not gonna
Right,
do
but
that.
you're not doing a solution. You weren't finding a solution. You're just finding the identity. In an identity matrix, you're supposed to be multiplying for both sides and still get the identity. In this one, I'm specifically solving for X and Y, right? By finding the inverse of this, so I can cross it out and then just have X and Y here, and then I multiply the inverse because what I do to one side, I have to keep it balanced. So I have to multiply it, or else the equation is no longer balanced. Whatever answer I get there is my answer for X and Y. Okay. So let's do it. Let me just do 2 by 2, 2 by 1. So that means our X would be a 2 by 1. Okay. All right, so first we're going to find the inverse of this. If you guys look in your books for the equation of the inverse, for 2 by 2 it should be easy, right? It's 1 over the determinant on page 381. It's 1 over the determinant, so 1 over, can you please close the door, Paolo?
Oh.
The determinant is 2 times 5, so it's 10 minus 3 times 3, which is positive 9. And then I take what? I take these two and I flip it, so this 5 and 2, and then I change the sign, so this is 3 and 3. So that would be 1 over 1, 5, 3, 3, 2. So in this case, our inverse is 5, 3, 3, 2. This is a negative 1.
That's not all.
That's just the inverse. That's us finding the opposite. It's us finding what to do here, right? Is that this is my A, right? This is my B, and this is my variable matrix. So according to this, using inverses, I would multiply this by A to the negative 1, and this cancels out because it would be the identity matrix, leaving me with just what on this side? X and Y. And then I would have to take B and multiply this by a negative 1. And what has to be first?
The inverse.
The inverse. So it's 5, 3, 3, 2 times negative 1, 3. Yes?
Yeah.
Okay, what's the first thing I need to do when multiplying matrices?
The key.
The key. This is a 2 by 2, and this is a 2 by 1. So my key needs to be a what?
2 by 1.
A 2 by 1. That means how many rows and how many columns?
2 rows and 4.
Row 1, row 2, column 1. So row 1, column 1, row 2, column 2. Okay? So then let's start. You guys know how to do this, so you can do it with me if you'd like. R1, column, so R1, row 1, column 1. So 5 times negative 1 plus 3 times 3. And then row 2, column 1. 3 times negative 1 plus 2 times 3. Giving me 5 times negative 1, negative 5 plus 9, negative 3 plus 6. And this is 4 and 3.
So x, y is 4.
So x equals 4 and y equals 3. Questions on this? Now this is about the same work as if you were to use substitution or elimination, especially when you're adjusted to matrices. But on a 3 by 3, this is a lot less work than finding the identity matrix or using substitution or elimination. Let's first put it into a matrix. So 4, negative 5, negative 3, and 2. Whoop. This is A. Yes? A sub 1, right, is going to be, I'm going to take this first row, okay, and I'm going to replace it with this answer. So negative 49, 28, and then negative 5 and 2. Everything else stays the same.
Oh,
Right?
I remember this.
So you replace, whatever this number is, you replace that column with the answer. Yes? And then from here, A sub 2 would be what?
It would be
The answer's in the second, yeah.
4, negative 49, 3, 28.
Yes, negative 49, and then 28. You with me? And if there was a third, if there's a third variable, I do the same thing. I do it for however many variables there are. You with me? And that sign, so for example, x1 would equal a sub 1, and this is not absolute value, it means the determinant of a sub 1 over the determinant of a. Right? And then x sub 2 would be the determinant of a sub 2 over the determinant of a.
What does that mean?
Huh?
What does that mean?
The determinant, the this times this minus this times this.
No, yeah, I know what that is, but so you would put that
So,
number
so each,
for
yeah,
A,
so
one,
each of
two,
these
and
represents
for A.
one value. They don't represent matrix anymore. They represent one value, and you put that value over this. And if that makes no sense, we're gonna run the first one, and you'll see.
Wait, so the determinant, what happens when you have, oh, I remember.
Right, so the determinant is a sub 1 over a. So let's find the determinant of a first, okay? The determinant of a is 4 times 2 minus negative 3 times negative 5. 4 times 2 is 8
8 minus 15,
minus positive 15, which is
negative 7.
negative 7. Yes?
Yep.
So this one would be x1 equals negative 7 on the bottom. x2 equals negative 7 on the bottom. Yes?
Yeah.
So now we have to find the tops. I just have to find the determinant of this then. So, the determinant of a sub 1 is this times this, so negative 49 times 2 minus negative 5 times 28. What's negative 49 times 2? Negative 98 plus 5 times 28. Huh? 40 or 48?
No, 140.
Okay, and then negative 98 plus 140.
42.
Huh? 42. So then this is 42 over negative 7.
Negative 6.
What?
It equals negative 6.
Oh, sorry. What did I do?
No, 42 divided by 7 is negative 6.
Oh, okay. I thought,
Sorry.
it's fine. Negative 6 is x1. And then x2 is the determinant of a2. So 4 times 28 minus negative 3 times negative 49. So 4 times 28,
112.
112 minus negative 3 times 49.
147.
Yeah.
You sure?
112 minus 147? 112 minus 1,
Yeah,
huh?
it should be negative 35.
Negative 25 or 35?
35.
So this is minus 35, which means x2 is
5.
positive 5. So my answer is negative 6 and positive 5, which I can write it in that same format as negative 6 and 5. Whichever format, I don't care.
Oh, what? That's the answer?
Yep.